Hello, and today we're going to be talking about the Argand diagram. And what this is it's essentially graphing complex numbers. Now, this is also known as the complex plane or the imaginary plane. So these are all the same thing, but here they are. So what I have in front of me is a graph with a circle in the middle. This circle is the unit circle. It is sometimes drawn in on graphs, the unit circle, when it comes to this Argand diagram. So now, what are our units? I'm going to get rid of this circle. What are our units? Well, on the x-axis, we have the real part of z, and on the y-axis, we have the imaginary part of z. So now, with this system of units, let's actually do something with them. I'm going to define a z value up in the corner here. Z1 equals 1 plus I, and then I'm going to graph it. So 1 plus 1I, that's going to be here. So this is Z1. I'm going to draw in some sort of kind of like a guideline. So there you go, there's Z1 is there. So now I'm going to plot the complement of Z1. So now I'm going to plot the conjugate of Z1. And I'm going to write down what that actually is. It's going to be 1 minus I. So in a different color, I'm going to draw in the conjugate. So, and here's Z1 conjugate. So now I want to put in a different Z value. I'm going to call this Z2 and I'm going to make it equal to 2 negative 2i. So I'm going to put it in. This time I'm not going to do guidelines as what I've done before, but there you go, there's Z2. So if I wanted the conjugate of Z2, what does that equal? It's going to be 2 plus 2i. So that's going to be going up and about here-ish. So this is Z2 conjugate. So now if we wanted to express this visually, what has the conjugate actually done to these points? Well, you can say that it's been reflected. How has it been reflected? It's been reflected from the x-axis here. So the y values become negative, or the negative y values become positive, and it's just reflecting back and forth. So here we have a z value, and it's 1 plus I, and I'm going to get this z value and I'm going to times it by I. So now what is it going to be? It's going to become 1I times plus I squared. This is going to become negative 1, so I'm going to plot that. So 1I, negative 1, and it's here. So this is IZ. So now I'm going to times it by I squared. And I squared, going back to the power of I squared is just negative 1, so it's going to be negative Z, so it's going to become minus 1 minus I. So I'm going to plot that. That's here. So this is I squared Z. And now I'm going to plot I to the power of 3 Z. I to the power of 3 is just negative I. So it's going to become negative I minus I squared. It's going to become positive 1. So negative I, positive 1. Going to go here. Z I to the power of 3z. And now I'm going to write I to the power of 4 of z. I to the power of 4 is just 1, so I'm left with 1 plus I. And you can see that this loops back. So what have we done? We have essentially... So let's actually draw a line from each of these points, just so we can visualize what's exactly happened. You'll see that in some textbooks they'll actually put in a line going to each of these points. This isn't perfect, but what's effectively happened is that we've rotated 90 degrees every time we multiplied by an extra I. Or in radians, we've moved pi over 2 radians. So this becomes very useful later on, thinking about angles. So we're moving anti-clockwise. So now I want to talk about this brown bit here, this line that we've put in. So this line can be represented in two different ways. So let's say z is equal to 1 plus I like we had earlier. And this is our graph. Here's z, and I want to work out this distance. The distance from z to the origin, so the thing in red. So what we do is we have a special notation, modulus of z. This is also known as r. How can we work out this distance? Well, we can use Pythagoras. We can just use that, make it a right angle, and then we can just square both of the sides. So what we get is the y value, which in this case is 1, and the x value, in this case is also 1, and we can solve. So for this particular z, going to be 1 squared plus 1 squared square rooted. And we can make this general by saying that the absolute value of z is equal to x squared plus y squared square rooted, thanks to Pythagoras. So for this particular z, 1 squared is 1, so 1 plus 1 is 2, so the distance is root 2 from the origin. So that's all the time that I have for today for complex numbers. If you have any questions, feel free to leave a comment in the comment section below or contact me on social media, and I will see you in the next video.